Hi, this is Olivia Stodig, and in this short video, I will show you how to test your components locally before integrating them into your Dapta workflow. So I will be using the Dapta web app, which you can now try out for free by going onto dapta.com and clicking the Try It Free button here, which will give you access to your dashboard. So let's start by defining what a component actually is. So here I have the Dapta web interface open, and I can create a new component by right-clicking and selecting Add Empty Node. Now I can edit this empty template by clicking onto it. I can provide the component with a name. Let's call it paraboloid. And I can select an API. In this case, we will be using the generic Python 3 comp. Once I've selected this, I can see that my component will require a setup function, a compute function, and possibly some requirements. Components also have parameters, inputs, and outputs, which are dictionaries that define variables outside of your code and make the code more standardized. Inputs and outputs specifically allow you to expose variables to other components, which allows you to create connections between components, and it also allows you to automate the execution of workflows with different input values using drivers. Now, let's look at an example of creating a new component locally. So to test our component, we will start by choosing a template, modifying it, running it locally using Python, and then finally uploading it to the Dapta cloud to run it. So let's start with choosing a template from the docs. So if I go back to my interface, I can see I have my empty component here, and I can access the docs by clicking onto the Help button on the top right. Here we will be using the simple component analysis as a starting point. This is a simple paraboloid analytical function which is defined in Python. And I can see that there's a link here to the GitHub folder with the input files. Here I can access the compute, the setup function, as well as the parameters in this .json file. So let's have a look at the compute function. This is a Python script, which is relatively short. And you can see here at the bottom, I'm calculating fxy, which is an analytical function of our inputs x and y. Let's take a copy of this. Okay, now that we have a copy of this, we can look at editing it in your favorite code editor. So in this case, I'm going to use Microsoft Visual Studio Code. And I'll open it next to my web interface so I can look at both at the same time. Here, I will create a new file called compute.py and paste in the code that I've just copied. I've also got a terminal window open here at the bottom, which will allow me to first define a local Python environment. So this is important so that I don't install all of my requirements in my machine environment. So in Linux, you can simply use venv to create a local environment. So I will be using Python 3 -m venv. And as you can see, this creates a new folder called env in my local directory. Now to activate this local environment, I need to activate it using source bin activate. And now you can see that here this prefix is indicating that we're using our local env environment. And the code editor has also picked this up, which is great. So clear now. So if you had any specific requirements, which we don't have here because we're not importing anything out of the ordinary, then you could add those requirements to your local environment. The one thing that we will be doing is adding Bandit to our local environment, which allows us to check for common security issues in our Python script. And this is a good idea for local testing because the Bandit script is also run when you upload Python files to the Dapta app, and therefore any errors that you get when you upload, you can actually test here by running Bandit locally. So if you search for Bandit online, you can find this Bandit web doc. And to install Bandit, we just need to pip install it. So let's do that. Okay, so that worked. Okay, so after installing Bandit, we can also quickly have a look at what other libraries we could install. And this is if we go back to our docs. So let's just reverse this. We have here a frequently asked question section. And we can also have a look at which Python packages are currently available. So this is a list that gets updated regularly. And if there's anything that you specifically need, you can have a look here. And if it's not in there, you can request it by just sending us a message. Okay, so if we go back to our script. So let's go back into GitHub and have a look at this again. So what we can see is here the file we've copied is actually just it just has one function in it, but it has no way of executing that at the moment. So the first thing we need to do to test this locally is to allow us to execute this function. And to do this, we're simply going to add an if statement to the bottom of this file, which will get executed when this file is called from the command line. So we'll add this statement here. And then before we can call our compute function, we want to define some of the standard inputs. So we can see here that we will need to define some design inputs. We don't need to define the outputs yet. And the partials, we don't need either options. We will need to define something here, and parameters. We can also define something which will allow us to have a run path. So let's do that now. Okay, let's call our function compute. So that's our compute call, and then we'll just print the output from that. Okay, let's save that. And now we can actually try and execute this. So we're in the right folder, and so we can just call now Python compute.py. Right, so we can see that actually we do need to define outputs because we're actually setting this value directly here. So let's define it in our dictionary. So let's call this design outputs and add the outputs here. So this is great because we're actually finding out what doesn't work before we try to run this in the cloud. So we'll have to set this to some initial float value. And now we should be able to execute this. We get another error. So we see that the options get grads is missing. So we can define this in here as well. And at this point, we're just going to set this to false because we don't want to calculate the gradients for this example. And okay, now we get what we expect when we execute this Python compute.py. And we can see that we've got our fxy calculated as 107. So if we wanted to add a little bit of testing to this if statement, we could simply add a assert. So here we're simply testing that if we round our fxy output divided by 107, we're very close to 1. If it's not, then we get this error message. So for example, if we now went into our compute function and we modified one of these factors. Let's say execute this instead of squaring it. Now if I execute this again, I get this message here. And I can see that my fxy is actually 111 and not 107 as I would expect. So clear that and revert our change. So if I run this again, now it should be fine. Okay, so we're getting what we expect again. Now the other thing we can do is to create a function which allows us to record these outputs here to a run log, which allows us to see this once we are running the script on the cloud. So to do this, we'll simply create a wrapper around our compute function. So at the top here, I'm just going to create a new compute function. So it's important that the top level function still remains compute. So we'll rename this as main. And the inputs to this are an exact copy of our previous inputs. So we'll just copy that over. And what we will do here is to call our main function. And return the outputs of that. Okay, so, and again, we'll copy that over. So let's save that. Okay, so this looks better. So we now put a wrapper on this. We say that we want to open a file first. So we'll call this open, and we'll just call this run log. And we have a new call here, which is with redirect standard out. And this is a wrapper around our main function. So we haven't actually defined this here, so we need to import this from a standard library. And that standard library is context_lib. So from context_lib, import redirect standard out. So now we should be able to see that we've got this defined, which is correct. The other thing that we might want to do is also import a timer. So we can do that here. So we can see how quickly our functions work. So we can import time. And the timer, I'm just going to copy something that I've prepared here previously. So this is a decorator script, which allows us to capture a time when a function starts and when it stops, and return the difference between the two as an output, as well as print something to the command line saying how long it took. So we've got that in here. And now we can use this at timeout as a decorator. So we'll call this on our main function here. So we'll just say at timer. Okay, so this should run now. So let's try that. So we still get this in the command line output. Why is that? This is maybe because, yes, of course, we are printing our output here outside of our compute function. So the output that we're getting on the command line here is our print response here, which is executed afterwards. So let's move this into our function call. So let's just print the response here. Okay, and let's execute that again. So now we can see that we haven't got anything on the command line core here, but everything gets written to this run log text output. So and we can see here, of course, we've got our function output, but we've also got the output from our timing wrapper. So, for example, if I put in a little pause in here to make this last a bit longer, so we can put in sleep call. And then run this again. We'd see that our run log updates here, and we can see that our function execution time has increased to about a half a second. Okay, now finally, we shouldn't be saving data to our local directory because we don't really know where this is going to be on the cloud. So we need to make sure that when we save something as an output, it goes into our run log folder. So this is our outputs folder path here. So what we want to do is add this into our function path when we define the run log. So let's say if we run this again, let's just check this works. Excellent. So now we have this run log, which should be identical to our previous run log. So with this, we almost finished testing our component locally. The one thing we haven't done yet is called bandit. So we need to do that now to see if we'll get any problems when we try to upload this to the interface. So let's just minimize all of this. And let's call bandit compute.py. And now we can see that we've got some output here. And we do have one issue. So bandit detects the assert statement. So this is something that's a low criticality, but it tells us that this is highlighted as something that we should remove if this is a script we plan to run outside of testing. So if we just comment that out, and anyway, this is not the way that we'll be executing our component in the interface. So we can remove this for now. But this allows us to do the testing again in the future. We're just commenting it out if we want to. So if we now run our bandit compute again, we now have no issues identified, which is great. Okay, so now we're ready to copy this into the cloud. So if we now go back into our Dapta environment, we didn't save this originally, so now let's start this again. Roboloid. This is a generic Python component. We haven't selected a setup, so we can just copy the one from the example. Let's copy that. And save that locally. So we can now upload our setup, compute. We have no requirements. This is our start and end node. So we're not going to define any parameters here and see what happens. And for the inputs, we will define X and Y as we had previously. and the output will be our fxy function. You can save that. And now we can try and execute that. So we get a message that the run has completed successfully. And we can look at our run log to see what happened. So we can see here a summary of our expected output. So we have a message here that tells us that our inputs were 5 and 5, and our output was fxy 107. And we can also download our run log by downloading a file snapshot. So we'll just put that in here. And we can look at the outputs here. So this will just include our run log, and that is exactly the same that we had on our local machine. So let's recap what we've done so far. We actually, in 3 steps, created a component and then tested it locally. So we took a component template from the docs, modified it, and tested it locally, including running Bandit. And then we uploaded it and ran the component in the cloud. So that's it. Thanks for listening.